Here we're going to do 13.2 part C, but that part C is going to be dealing with the unit circle and how to fill it out. And then the 10 minutes or less I have, I want to put in everything I know about a unit circle on this screen. Okay, so to start, let's write down what we know. Okay, we know that this is 0 degrees, 90, 180, and down here is 270. And if we go all the way around, it's 360. The points on here break down the circle into the degrees that we looked at with the special right triangles. Here we have 30 degrees, then it's 45 degrees, then it's 60 degrees, and then 90. And if you continue with that increase, this would be 120. And if I go by 60s, if I go by 30, it'd be 30, 60, 90, 120, 150, 180, and then we got 210, 240. I'm skipping the 45 degree markers if you haven't noticed. 270, 300, 330, and then 360. The 45s, we have 45, 90, plus another 45 is 135, plus 45 is 180, plus 45 is 225, plus 45 is 270, and it's 315, plus 45 is 360. Now this represents all the degrees. Now let's do radians. If I go by radians, it's 0. And I'm going to do the easiest ones. Up here it's pi over 2. Over here it's pi, 3 pi over 2, and then 2 pi. If I break it up into fractions, if this is half a pi, and this is 1/4 of a pi, so pi over 4. If I follow that around, pi over 4, this would be 2 pi over 4, which reduces to pi over 2. This would be 3 pi over 4. And then 4 pi over 4 reduces to pi. 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4. And 8 pi over 4, which reduces to 2 pi. Now if I break it into pi over 3, so 60 degrees is the same as pi over 3, a third of a pi. Then 2/3 of a pi, or 2 pi over 3. 3/3 is pi. And it's 4 pi over 3. 5 pi over 3. And 6 pi over 3, which is 2 pi. Then we go by 6. So if I go pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. And it's 4 pi over 6, which is reduces to 2 pi over 3. And it's 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. And 11 pi over 6. Everything else reduced. 11 pi over 6. Okay, that's our radians and degrees. Now we're going to put in our trig functions. Now trig functions are a coordinate at these points, and they're in the ordered pair of cosine of theta, sine of theta. Cosine first, sine second. If we do the easy ones, cosine of 0, or in other words, let's do this. This is a unit circle, so the radius is 1. So this coordinate is 1, 0. This coordinate is 0, 1. This coordinate is negative 1, 0. Down here, the coordinate is 0, negative 1. I know this because it's a unit circle, which means the radius is 1, and you're centered at the origin, right there. Now, on the chart we had a day ago, we talked about the sine of 30, the sine of 45, and so on. Cosine of 30, cosine of 45. What this graph tells us is that I can look at this coordinate and I know that the cosine of 0 degrees is equal to 1. You can check that on your calculator. And the sine of 0 degrees is 0. And that's right here. So the coordinates will tell us what the trig function value is at a radian measure or a degree measure. If you look at your special right triangles, we can fill this in. And the easiest one to do is to say sine of 45 and cosine of 45 were always the same, and that was root 2 over 2. Root 2 over 2. And the other ones, 30 degrees, cosine was root 3 over 2. And sine of 30 degrees was 1/2. 60 gave us a cosine of 1/2 and a sine of root 3 over 2. Now notice that the cosine of 60 and the sine of 30 are the same. And it's this quadrant that's going to tell us what everything else is. 45 are the same. 30 degrees and 60 degrees simply reverse the x and the cosine and the sine values. Here's where we need to remember this important part of the quadrant system. In a coordinate in this quadrant, both x and y are positive, and the same goes for cosine and sine. In this quadrant, x's are negative, or in this case cosines, and sines are positive. In this quadrant, they're both negative. In this quadrant, x's are positive, y's are negative. In other words, cosines are positive, sines are negative. I'm going to stop here so that I have time, and in my next part, I will finish completing this unit circle.